Okay, so we talked about how you can create a list of rules in linguistics, how that's actually the main goal of syntax, is to create a list of rules that describes how the language creates well-formed or grammatically correct sentences, and make sure that those rules do not allow any ungrammatical sentences. So here's an example of a very small grammar with a language that actually has only 1, 2, 3, 4, 5, 6, 7 words. And this grammar should allow us to create sentences that are grammatical and none that are ungrammatical. So we talked about that and how we can do that. So this is called a context-free grammar. And by following these rules, every sentence can be produced. The rule is that you have to start with the S rule, and then you can replace that with whatever's on the right-hand side. So in this case, a noun phrase and a verb phrase. And then you keep on going until you've produced a sentence. You get down to these non-terminal nodes. All right, so we trace that with an intransitive sentence. So this is a reminder, these little bars here mean or, meaning that you have to choose one or the other of the things. And we traced this grammar with those rules in mind all the way down, replacing what was on the left-hand side with whatever is on the right-hand side. So S is replaced by NP and VP, NP is replaced by determiner and noun, and the determiner is replaced by either a or the. And we can do that with all of these so that we end up, and in this case we chose intransitive verb, we end up with a dog sleeps. So that works, that's a grammatical sentence, great. We can also do the same thing and choose a different rule. So in the options where we have more than one, so the VP we could either do intransitive. So let's trace this through with a transitive verb and see how that works. Again, replacing whatever's on the left-hand side with whatever is on the right-hand side. It's the same thing here. We'll do the same thing with the determiner and noun rule. When we get the VP, we'll do the transitive verb rule. So transitive verb plus NP, and then keep on replacing till we end up with this sentence. A dog hates the cat, which works. It's a grammatical sentence in English. So this has been generated correctly by this grammar. And we've seen there that that's a derivation, step by step. We replace whatever on the left-hand side with the right-hand side. But in linguistics, we actually show that much more simply with something that's called syntactic trees. And it shows every step, but in a simpler way. So it shows every step we need to produce the sentence using the grammar. But in a simpler way, it's shorter. So you can see, here's our syntactic tree. And you can see that an S is made up of a noun phrase and a verb phrase. A verb phrase in this case is made up of a transitive verb plus a noun phrase, which is made up of a determiner and a noun. And that's all correct. It's all produced using these rules. So what if we want to do the recursive sentences that we saw earlier on Wednesday? So we can start with our rules that we have here. So to do this, first of all, we can start with what we have, but we have to add a couple more rules. So first of all, for the verb phrase, we need to add this recursive rule that has a verb, which we'll call VC, a comp, which is short for complementizer, it's a connecting word, and then the S. So this is where the recursion comes in, that we have our S right here coming in. And let me make this a little bit easier to see. There we go. So we have to add this recursive rule to the VP, and then we need rules for the things that we're missing. So for the VC, we are going to add a new rule with words that allow this recursion to happen, thinks and says. And then we're going to add this rule for the complementizer, the comp, which is simply this connecting word that, which is required in English. And then we have the rules for S. So this is where the recursion starts. So in this case, we've got our syntactic tree, and we come down here, and in the VP, we're going to use a recursive rule with the VC and the comp. And then the rest is fairly simple. We already have the rule for S, so we just add that in there. And we can create this longer sentence. A dog says that the cat sleeps. And we could actually keep on going, right? So that's the thing about recursion, is instead of this intransitive verb here, we could keep adding this recursive rule on and on. Theoretically, for infinity, because we can keep on reusing the same words over and over again. So we have this grammar, which is now generating grammatically correct sentences, including sentences that are recursive. Maybe if we think about this generation process with from these rules as function calls in programming, we can actually model this grammar and potentially any grammar of any language, no matter maybe how detailed it is to cover all the exceptions, we can model that using Python. So in this case, we would start with a function s and would call s, which would call a function np and then call a function vp. But first the function np would call the function determiner and then later the function noun. And determiner then would not call another function, it would print out the word, either a or the, and then return. And return to where it left off, which would then, the next thing would be to call the function in, which prints out a word cat or dog, and then return up to np, and np would return up to s, which would then go to vp, and et cetera, et cetera, et cetera. And we could end up with something like this, something that's modeling this tree with function calls. And at the end, it's printing out. So what we're seeing coming out would be a grammatical sentence. And if we did it correctly, then it would be able to generate any grammatical sentence and no ungrammatical sentences using the grammar that we have. So S would call NP, which would call VP. And of course, these would get called, as we said, it would print, return, go to NP, print, return, which would return NP to S, which is then called VP. And VP would call these functions one by one, which they would then, and here's where we would get the recursion, where S then is modeling the recursion language, which it would do this whole thing over. It would call the NP and then the VP and so on and so forth. There's a couple of issues here though. There's a couple of things that we need to do that we don't have the tools yet to do in Python. So let's look at these problems. So the first problem is, how can we get a function like determiner to print out a random word? So we have either a or the. It would not be correct to print out both of them. We need to pick one of them. And if we want to generate all possible sentences just randomly, then we need to be able to choose that word at random to see if the combination of all of these actually work, if they're chosen randomly. So the answer is we can use Python's random.choice function. So we've learned that there's some built-in functions in Python. Python also has some what we call packages or library of functions, which we can get. It's built in, but to do that, first of all, we need to import them. So they're there, but they're kind of held in a different spot, so we need to import them. So to use this random.choice, the first thing we need to do is import random in our code. And that's usually at the very top of your code. It doesn't matter as long as you import it before you call it. So we would import random, and then we could have a list full of words, so in this case cat or dog, so that's our noun list. And then we would call random.choice, pass our list to it as an argument. And what it would do is choose a random word, either cat or dog, since that's what in our list. So a random element, one single element randomly from our list, and return it so that it would now be assigned to a word, the variable. And we can then work with that randomly chosen word. So that solves our first problem of how do we get random words from a list of words. The second issue is we have these rules where there are, at the VP in particular, where we need to choose a random sequence of functions, not words. So the VP needs to either call the VI or the VT NP rule or the VC comp S rule, not all of them. We need to choose it randomly and then call those functions. So how do we do that? Well, let's take a closer look at functions in Python. one of the nice things about functions is that they can actually act like variables, or the function names, I should say, to be precise. So in Python, functions can be passed around and saved and assigned to other variables and put in lists and everything else, just like any other variable. So if we have this function definition, say hello, which prints hello, we can take that function name, and just like any other variable, we can assign it to another variable, in this case, x. And then we can pass this thing around, we can do things with it, and when we want to call it, we simply pass the arguments to it. So in this case, there's no arguments, we just put those parentheses. So this is the point at which the function would be called, when we had these parentheses. So we can take the function name, pass it around, use it like a variable, and then we want to call it, we simply make the call by passing its arguments to it in parentheses. So in this case, if we, that line, x with parentheses, would print out hello. So with this, we can take the function names, and just like any other variables, we can create lists of functions. So we can have a list of variables, we can have a list of string literals, etc. So we have two functions here, say hello, which prints hello, and say goodbye, which prints goodbye. We can take those function names and create a list of these functions, which has its variable name, right? List of functions. And then we can do things with those functions in the list. Notice the parentheses are not here, so they're not being called here. If you put the parentheses in the list, it can do interesting things to your code. We're taking the function names and using them like variables instead. And once we do that, we assign it to a list, we can then do something simple like loop through for I in range length list of functions. And then we can use the I to index into the list, grab the function, and then at that point, or wherever we want in our code, we can then make the call by passing the arguments. In this case, just adding parentheses. So this code snippet here would first call say hello and then call say goodbye. And in this case, it's the same as if we had a line say hello parentheses and then another line under it say goodbye parentheses. It's the same thing, but we can combine this with random.choice and get more interesting and variable code that's doing interesting things. And in our case, we can use it to model a grammar, perhaps. So we can, again, we need to import random. Then we have our two function definitions. Again, we create a list of those function names. And in this case, we do random.choice and feed it our list of functions. And it will choose a random element from the list, assign that to the variable random function, and we can then call that random function. So that's either going to call say hello or say goodbye, whichever has been chosen randomly by the random function. So having solved those problems of how do we call a random element from a list, and the fact that we can also treat functions like variables and then put them in list of list and call a random element from the list and then call a random element or loop through a list of functions and then call them as we want. We now have all the tools we need to model this grammar and generate any possible sentence that this grammar can create and make sure that it's working correctly. So in this case, it should create grammatical English sentences. And that is exactly what homework 3 is asking you to do.